As always, we have a pretty stellar lineup of speakers and talks that will carry us all the way to the closing keynotes. I guess without further ado, let's get started by welcoming Don and Daniel from Omegapoint to talk about Secure by Design Revisited.
Thanks.
Thank you.
Thanks, great.
All right, so Dan, this morning I think we got some praise and promotion by Erika and Tobias in their talk about, defense in depth, right?
Yeah, and there's secure APIs and how to defend them. And they did a few shout-outs at Terra, but that seems like Secure by Design should be something that just gets you started and makes things secure.
Yeah, and that was fantastic. The only problem with this was that, they told you to come to this talk on main stage, and we picked a talk where we're going to do some self-criticism.
So this feels a little bit odd. So welcome here, everybody, and I hope you will enjoy us hitting ourselves over the head for some things that we think we said and how they perhaps not turned out what we intended. But we hope that in the end it will turn out into something that's worth for you to take with you.
Yeah, this will be a learning experience. Fantastic. Okay, so let's see if we can see the first slide there. And here's the most boring slide.
That's him.
Yeah.
That's me. Google us. We wrote a book together with Daniel Savano. You might be familiar with it. We're going to pick a few ideas out of that and see how those things look in a perspective of a few years down the line.
So, right, this is the agenda. Since not all of you, for some reason, do not know what Secure by Design is, we figured let's
you could read the book.
Minutes. Well, yeah.
Just a possibility.
We will get you on the same page. That's good. And then we're going to focus on three things.
So we're going to have a look at three different design patterns that we took out in the book and lifted and said, this is a good way of doing it. And that might not always have turned out as good as we hoped for. So we're going to have a look at domain primitives as one of them.
The importance of validation. How easy doesn't that sound? How can that be wrong?
And the practice of externalizing secrets. And for each of them, we're going to dig a little bit deeper, look at what we said, what the misconceptions we have seen, what we really meant, and what kind of insights we can take away from it.
And the awesome thing is that you guys will bring this back to your daily work and don't step into those pitfalls. So that's good. Yeah. Right, let's move on. So summary, Dan, in case they have to run to the bathroom or something.
Or fall asleep or for whatever reason. So Secure by Design, it's a mindset. It's a strategy for creating software where you not have to think about security consciously all the time, but instead piggyback on our natural drive to do good design.
And when it comes to domain primitives, it turns out that for some reason, there was so much focus on the security aspect that they have turned out to become anemic. And that itself creates another security problem, right?
When we look at what we talk about on input validation, we have realized that speaking about input validation has put state validation in the shadow, which opens up for another set of problems.
Yeah, and then there was a dead end, right? I think when we talked about externalizing secrets, people have, unfortunately, they thought they were moving in the right direction, but they ended up in a dead end. And
we didn't realize that config injection, that startup, was as much of a dead end as we thought. So we'd like to point you in another direction.
So, but this will all make sense to you after our talk. I hope so, anyway. So let's start with this question, Dan. What is Secure all about?
Well, let's have a look at it from a slightly another angle. When we write software, what is our primary production? What do we create the most of? We create bugs.
Yeah, that's what we develop, right?
So this is a visualization of a system or the realm of functionality. And when we are coding, we're creating bugs. And bugs are most often not like typos. I was going to write equal, but accidentally write not equal. It's more like slight misunderstandings that makes the code misbehave. And for some things that just turn out to be the wrong color of a button.
Okay, so you're saying that some bugs, they could be the wrong color of a button, whereas others could be losing money or, I don't know.
Some kind of security problem. So meaning that they degrade the system on some security concern.
Okay.
Confidentiality, integrity, availability, traceability, some of those aspects are degraded. And then we call them vulnerabilities, security bugs. But they are just bugs. So how do we avoid bugs?
Well, we apply a design pattern, right? I mean, we try to address the problem.
For example?
I don't know. Dependency injection.
Okay.
That's a design pattern.
So will dependency injection reduce the risk of all bugs in the universe?
Well, I wish. Yeah, but no.
No, typically a design will reduce the likelihood of a small sub-realm of the possible bugs. Some of those bugs happen to be security bugs.
Oh, okay. So you're saying that the pattern in itself did fix the problem that we were talking about, but also bugs that have a security relation somehow.
Yeah. So thus they help us being more secure, even though the driver of using that pattern is not security.
Okay.
It's just a neat by effect.
And I assume that there are a lot of different design patterns out there, right?
And they will sometimes overlap of the kind of bugs they reduce the likelihood of, sometimes not. No single pattern will reduce all bugs, but there's some of these patterns that are a little bit interesting, and I think some of them include these triangles. So these are design patterns that actually have interesting security by-effects.
Okay. So in the green ones, they cover security problems, and therefore they are to be seen as secure by design patterns.
Yeah, definitely. But there are also the two on the top and the bottom.
Yeah.
They all include a large amount of bugs, but unfortunately not security-related stuff. So what do we say about them?
Okay, they're fantastic design patterns, of course, as you all know. They do fix issues, but they do not fix security issues.
So we're trying to stay a little bit honest to ourselves and saying that we love design as much as the next developer, and we love collecting nice design that gives our code a lot of qualities. But for the purpose of Secure by Design, let's stay true to just talking about those design patterns that also, as a by-effect, reduces the likelihood of security-related problem.
Okay, so you're saying the primary purpose isn't to fix the security problem, it's rather to build good design.
So that's what we're talking about, piggybacking our drive to do good design.
That brings me to the next slide, because we couldn't draw that picture in a book, we had to write something clever, right? So we wrote this, that Secure by Design is a mindset and strategy, because that sounds good, for creating secure software by focusing on good design. Right?
Sounds pretty good.
Sounds pretty good.
And we have seen quite a lot of good results as well, where we ourselves and other teams that we have audited have been consciously trying to use designs with a Secure by Design quality, and they have got lesser amounts of bugs, which is nice. But unfortunately, it seems not to be a golden bullet or hammer or whatever.
But something that I find very, very, how to say, like a nice feeling in my belly is that all of you are working with security if you work with good designs that turn out to cover security problems.
And this is something we often see as a problem, that even seasoned very skilled developers do not see themselves as security experts, but they are. When you are doing designs that you think are just nice, they're often also, that feeling of niceness, it's so hard to articulate what that is. It makes the code more readable, it makes the code easier to maintain, it makes it easier to test. If you start digging under those quality, you will realize that it also improves security.
Yeah.
So a lot of you are already security experts, and we'd like to encourage you to think about it that way.
Well, let's call it implicitly security experts.
Yeah.
Yeah.
So we're making a distinction here between explicit security expert and implicit security expert. So please put that on your business card.
Yeah. All right. So
Okay.
secure by design is, of course, quite big. We're not going to cover everything. The main focus in this area is what we also call the CIA, confidentiality, integrity, and availability.
Which are the classical triad of info security categorization. Keep the secret, confidentiality. Don't let things be changed in an unauthorized way, integrity. Ensure that things that are needed are availability. And then we got this extra traceability.
Yes.
Which is basically GDPR, ensure that who can see what, stuff like that.
And of course, we wanted to talk about everything, but we decided to focus on domain primitives, secure state handling, and something that's part of the 3 R's of enterprise security. So, now I think they all know what secure by design is,
Yeah.
right?
So let's dive
You're
into
good.
the first of the 3 patterns that we're
Yes.
going to cover. Domain primitives. We're going to talk about what we said, like what we've been saying in the book, what we've been promoting in conversations, on stage, etc. We're going to have a look at some misconceptions that we have seen in the field. We want to clarify what we intended to say, and then cover up some insights and self-critique.
Yeah, some self-critique. I think that's the fun part, right?
So, domain primitives, what did we say?
Yes. Okay, so this is how we expressed it, right? We said, a domain primitive, it's a value object that's so precise in its definition that its mere existence, its validity, it's actually only existing in a context where it's supposed to exist.
So this is a lot of words, and each word has got some kind of very pregnant meaning. But we talk about things that are native to the domain, like a phone number. It shouldn't be possible to construct an invalid phone number object, and would not need to describe it. It's actually primitive to domain. It's about domain representation, not about technical constructs.
So basically what we're saying is that that phone number can only exist in a context where that phone number is valid.
For example, a context might require that we only represent phone numbers to which it's possible to send a text message, ruling out landline numbers. So that might be a context in your application domain. Then we should craft a domain primitive around that only allow those kind of phone numbers. So it's not possible to create a phone number which contains some random digit string or whatever. But I think this might be a little bit clear. Let's dive into an example.
Example? Yes. Let's consider a Swedish tax ID. This is what most of you have in here. There could be some foreigners. They do not know what this is. But it's similar to a social security number in the States or wherever you're from.
So a typical tax ID might be 6605253225, which actually encodes a lot of information.
Yes.
So how do we represent this in code?
Well, first of all, you need to understand the business rule of this, right? Mm-hmm. First one being, it's 10 digits in total. We do have the 6 first digits. That's the birth date. Starts with year, month, day. Kind of nice. Then we have 3 digits for basically saying, this is your birth number. Mm-hmm. And then there's a control digit. And it turns out if you're over 100, you get a plus sign.
Yeah, that's weird.
That's pretty
good.
That
was from the old time when you did in a ledger. Then we just actually added a dash over the cross over the dash just to mark that this person is now 100 years old. So don't call them to show up for school at first grade when they're 107.
Or daycare, I guess.
Which actually has happened. I think that's fun.
Yeah.
So there's a lot of information encoded in this.
Yeah.
It's the date of birth, it's actually your sex, and for some periods it's also the region where you was born. If you're old enough, like me, it's actually tell me in which part of Sweden I was born. That has been abolished, so from some age that's not that information is encoded any longer.
But Dan, this is pretty complicated stuff. How should we represent this in code?
It's a string.
Okay. That was easy. Okay,
everything is a string, because Java is a stringly typed language.
Okay.
Everything is a string.
Okay,
so
if it's really complex, we're going to put it into a string because a string can represent anything.
Yes.
And then we're going to have logic that sort of assumes that that string is a tax ID.
Basically. It will probably like pick out some parts of the string and make some computation, or just register a newly born under that text ID. But it's just a string all over the place.
Okay.
Is this a nice representation of domain understanding?
No.
No. So what's the problem?
Well, the problem
from a security
is this.
perspective.
You know, as developers, we go like, yeah, tax ID, this is what I'm supposed to do, right? Because the variable name was tax ID.
Anyone had a look at a list of parameters and mainly paid focus to the right-hand side, the name of the parameter? Yeah. And then just had a look at the left side and say, yeah, it's a string or an int, because it's always a string or an int. Seems familiar?
Yeah.
So that is what we do as a developer, tend to do naturally.
Only the problem then is the attacker. They do not look at the variable name. They go like, oh, data type, string, what can I fit into that?
So when we as developer look at, let's make ensure that we can put in the valid data, they look at what's possible to input.
And there you go with the attacks, right? I mean, you get this.
So, dash, 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 drop table, etc. You all know little Bobby tables. So what we do instead?
The solution is, of course, a domain primitive, right? Because a domain primitive, what we said was that it's supposed to be a validated object that can only exist in the context where it's supposed to be used.
Which means that the text ID constructor will contain all those restrictions, so that it's impossible to get out with a text ID object without having to pass all those validations. So if I've got a text ID object in my hand, I know for sure that it is a valid format taxpayer ID, because otherwise it wouldn't exist. Its mere existence guarantee the validity.
This is mind-blowing, because what you have just said, Dan, is that you have decreased the attack vector to only be valid tax IDs.
Yeah, little Bobby table do not fit into the string any longer.
Okay, brilliant.
So how could this possibly go wrong?
I
mean,
no
this
idea.
is a brilliant idea. Let's promote it to the world.
Well, here's the misconception.
What could possibly go wrong?
Yeah, misconception, right? We have some code here. Okay.
Oh, wonderful code. What does it do?
Well,
okay, it starts out with a list of text IDs. That's good. Mm-hmm. And then for each text ID, it reaches into the value.
Okay, this is not the most prettiest code, but it's code, right? Okay.
And it starts tearing out stuff out of the inner working of it and interpret it as year, day, month, date of birth, and then check whether this person is 18 years or not, and then it adds to a list.
Yeah, this is because we want to find out who is eligible to vote based on the tax ID, right? If you are 18 or older, you're supposed to be able to vote, more or less.
Okay,
there could be other restrictions too, but let's assume that for simplicity.
So we have seen this kind of code. What's the problem?
What's the problem?
What's the misconception?
Well, the problem is that we are extracting everything out of our nice domain primitive, which is an intelligent object, right?
So what we intended to say, that domain primitives and encapsulating validity should not be seen as a brilliant new idea in of itself. It builds upon the basics, original ideas of object orientation, where interpretation is encapsulated inside object. And remember, encapsulation is not about data. It's not about encapsulating the data. Just making something a private field does not make it encapsulated in an interesting way. What's interesting is to encapsulate behavior and interpretation of that data. That is what is to be encapsulated. Alan Kay stressed this by saying that the big idea is messaging. Doing the interpretation is the object itself that does.
So if you look at this code again, what we see here is that on each of those lines inside of the for loop, we say id.value. Contain substring, whatever. Suddenly we are digging into that object, extracting that, even though we should probably have asked this object for, I guess, the 18.
So we are doing the interpretation on the outside of the object. That was not what we meant when we said domain primitives.
What we really meant was that the domain primitive should be a small, intelligent machine, right?
So what would that look like in practice?
Well, yes. So
according to Alan Kay, we should focus on messaging, which means that it's not the interpretation that's the important. That's not the implementation that's the important part of an object. It's the interface.
Yes. And if you look at this part here now, you can see that we have an interface on our immutable domain primitive that encapsulates all those rules and everything we had, right? And we could ask it questions like, gender, because that was part of the rules. We could ask it, it's eligible to vote apparently, which is kind of weird. But
okay, now we're making a pedagogical clarification here. That might not necessarily be the best choice of design. We just want to clarify some functionality that could be fit in the object instead of outside.
You have age was part of it, right? Or you can also ask it for some IDs. It can actually tell you which region you're born in.
So calling that on my text ID would yield Gothenburg, whereas if you pose it on for some of my either of my two sons, it would return none. Or
yes.
Empty.
All right. So that's an intelligent object. So if you look at the misconception again, if we had used that, the code would have become much, much, much simpler, right?
So
this is what we used to.
This is the for loop.
This is the for loop, yes. But it's written in a way that we should have done, right? We say that let's stream all those tax IDs, and we would filter out those that match our criteria, right? And we collect that into a list.
It's almost readable. You could almost take some domain expert and sit down with you and say, remember almost, you could take a domain expert and sit down beside you and say, let me read you the code. There will be some weird punctuation and weird parentheses, and the wording might sometimes be a little bit of Yoda speech. But let's read this, and they'll probably say, yeah, makes sense, sounds right.
Come on, Dan, we're at Jfokus. These people are bright. Right? We can't trick them anymore. We say, oh, where did all that logic go? We went out the door. Okay. No, it actually went inside, of course, the tax ID class now, right? So we have pushed it in there. And it's actually turned out to be discovered a bug when we wrote the code, right? You see that we have to also include the people that are born on the election day. or 18 on the election day.
They should be able to vote then. So another side benefit of this is, of course, that if we think about the big for loop method, what are the chances that someone will write a unit test that actually tests the specific case of someone being born on election day or turning 18 on election day? Perhaps, perhaps not. We often see a lot of unit tests not being there. With this design, the chance of someone writing a unit test for specifically testing the date of birth, eligible to vote, is much higher.
And it's going to be reused everywhere we need it. Okay, so let's go for the self-critique, Dan. This is the tough part on ourselves, I think.
Okay, so what did we do wrong?
Well,
first we must acknowledge that we think that security is an interesting trait of the domain primitives. It was the driver why we wanted to include that in our book and why we've been speaking of it in conferences. But
well, it's just a side effect, right? Remember, security wasn't our primary goal with this construct. It was really to create a clever building block inside of a context, right? That was validated, so we wouldn't have to write any defensive code construct saying, you know, if this is defined or if that applies and so on. We would just know. And the nice part about this, it would also give us the security benefit of preventing injection attacks.
It's a design with security benefits, although that design was not originally conceived for security benefits.
And we have to say this, I think, more clearly now. It's called secure by design, not design by secure. Right?
Something like that. So, this will be our first takeaway. When we're talking about domain primitives, yes, security is an impelling driver, but at its core, it is a design tool. Use it for designing intelligent value objects, which also include the validation, which is what we want to add.
And don't do them anemic. Make sure you encapsulate all that logic inside of it. Don't pull it out. Okay, good.
So, that was the first of our three. Now comes the second. We'll have a look at what we were talking about on validation, and especially state in relation to validation.
Okay.
So, what we said, misconception, some insights, and some self-critiques.
Yeah. All right, so validation, order of validation. This is what we said. You know.
Here's a shout out to Dr. John Wilander, who's the author or inventor of this list. Unfortunately, it hasn't been published in any peer-reviewed journal, so we can't scientifically cite it, but he's been presenting it all over the place. So, what was said about the order of validation?
Well, there are 5 important steps, right? We start with origin. Where did the data come from?
So if data comes from some weird IP address that we would not expect, or not through with an API key that we expect, then...
Well, we reject it, right?
We just reject it. So the first step protects the latter step of the order of validation.
Or we would look at size, right? Is it reasonably big? Like we expect a tax ID, not 1 million characters.
So if there's a tax ID with a 1 million tax ID coming in with 1 million characters, that's probably an attack.
Yeah.
So let's just drop that.
We also said that lexical content is important, and that means what type of characters are in there. Not what the order is, but rather which characters are there.
Like if you get a JSON string, does it contain what you expect, or do you have some weird characters like backspace reversed order or something like that? No, drop it. But if it contains what you expect it to contain, characters and encodings.
And then we go for syntax, right? Syntax is basically when we parse it. You know, does it make sense?
And we all know that parsing a JSON or an XML is a pretty computational heavy stuff, especially if the structures are big. So that's why we have the first steps to protect the parser. If we just let people throw stuff at the parser, they will be able to DOS us, because we are just giving our parser too much work to do, so it's just crashing.
Yeah, it's really easy to make it a heavy computation.
So now we know that the data comes from somewhere trusted, it's got reasonable size, it contains this kind of data that we expect, it has the appropriate structure, so now we can apply it.
Well, does it make sense to apply it?
You mean, for example, if we get that you should add something to an order, and that order is already closed, then it doesn't make sense to apply that to the order. That's the semantic validation. Does it make sense in the context? And typically, to do that, we have to hit the database.
Yeah, or something. But how could this possibly have gone wrong?
Okay, so we thought that it was clear, but then we realized now, 2.5 years later, that there is a slight risk of misconception of the word validation, because it's very easily interpreted as input argument validation. Validation is about the validity of the input data. It's not. It's not what we talked about. But in that case, we see that the first part, origin, who takes care of that one?
Well, that's usually part of the infrastructure, right? Your API, gateway, or...
Yeah, it checks IP addresses, client certificates, API keys, stuff like that.
Yeah. And then they said, input validation should be step 2, 3, and 4.
Yeah, size, lexical content, and syntax. This is a decent input.
And step 5, I don't understand what that is. I'm not going to do it. Of course it makes sense.
We're going to add it to the order. Of course we should add it to the order.
Yeah.
So this is kind of like false. It's not part of input validation, and thus it kind of like disappeared in the shadows. So if this is the misconception, what did we really mean? What's the clarification? Sorry, let's have an example of it.
Yeah.
So using the domain primitives that we had before, with an ISBN number, for example, the domain primitive contains the validation of the length, character, regex, checksum, whatever, and then we pass it to the book order, saying, add this book to the order.
Yeah.
What does the book order class do at that point of time? What does it do? What does it assume?
We sort of, of course, if this is Java, we say it's not null, right? We also check the inventory. And, if it is there, we add it to the order. And, we assume it's OK because we're inside of add book method, right?
Because the caller said, add this book to there. It's basically a command from the client saying, add this book to the order. So we'll just comply and do it. We are assuming that adding book is allowed.
Shoot, this is getting similar to the other example, like assuming stuff. That's bad. Assume is not good.
So how do we uphold that add book is not called when it's not a proper value?
Well, the only protection we have is that somebody hasn't written code that executes it, when it's supposed not to be.
Simply, we don't.
Yeah. Okay.
Why don't we add books when the order is closed? Because there's no code that does that. It's kind of like a negative proof. We just don't do it.
It would be kind of convenient though, if I ship an order, then I add stuff to it. That would be kind of good.
You are not allowed to write that code.
Okay. All right. Okay, so let's go back to what we intended really by order of validation, right? We said that, this is not input validation. This is validation of your entire object, right? Your state.
And here we must also add that when you say the word validation, in and of itself, it's meaningless. You always validate with regard to a model, with regard to your domain rules. You can't say that you validate phone numbers. You can't say that you validate orders. You must say, I validate phone numbers according to these rules. So saying this is a valid phone number or this is a valid order doesn't make sense. It always have to refer to a set of rules to which they comply.
So if we go back to our example again, then we would change this, right? Whenever we are in our add book logic, we have to check, does it make sense to add a book at this point in time?
So this is the 5th step of validation. Actively validating that you are allowed to do this at this stage.
And here's the key difference from before. We're not assuming anymore that it's okay to add something. We know. And that's a big difference.
The one who upholds this is the add book, the book order object itself. If we turn this into a REST API, we often see that you are allowed to, for example, post order something, then we create books, in that order. We might put things into shipment, say that this order should be put into shipment. And then if we later on post another set of books to be added to this order, what should the API react? In many cases, we just see that the API go, oh yeah, 200, okay. This is where the fifth step of validation should uphold. It should say 422 unprocessable entity, or 405 method not allowed, or something. So this is kind of a little bit ping back to you. Go home and look at your API definitions. Look at your OpenAPI JSON files and have a look at them. Do they ever say 405, 422, or something like that, that actually tells the client that, no, you are trying to push data on me that does not make sense state-wise at this moment? That's to up the game a little bit.
Yeah. So let's go into some criticism again, right?
Okay. Validation is often interpreted as input validation. Well, perhaps we have said that too many times.
Well, I think it could have been something that every talk we had and all the places where we presented, everything from domain primitives to when we talked about validation, we used examples of input validation.
So this, together with something that we have seen in the industry for a long time, that when people model their domains, state is often not explicitly modeled. We very seldom see a state diagram saying, well, this is the state diagram of our central entity. Instead, state is kind of like implicitly embedded by having some kind of if statement deep down in the code saying if, and then if this flag and this flag are not this flag, and the order is over that, and it's from blah, 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 and the date is, then some logic apply, else some other logic apply. What you have there is actually two distinction states, but it's not actively modeled. It's made implicit instead of explicit.
So we should have probably given talks about state validation instead. We actually wrote 2 chapters about it. So it's kind of weird that we never did
It's actually a little bit bizarre. 2 out of 14 chapters are about state. Yeah. How to create state in a consistent state, and how to keep that, and how to manage state in a secure way. But actually, until today, we haven't actually had a presentation covering those.
So we're really happy that we do this now at Jfokus. So that's good. Let's step out of that one. It's so hard to say all this bad stuff about yourself.
Yeah. Third to go. So we are talking about externalizing secrets.
Yeah.
Let's have a look at what we said, misconception, what we intended, and some self-critique.
Yeah, I think they know the drill now. Okay. So what did we say about externalization and secrets?
Our first observation was that secrets, like the password to the database, should not be part of the code. Okay? Because it varies from environment to environment. It should be part of the environment in which the code is deployed and run.
Basically, what we're trying to say is that you build your software once, and then you deploy it in different environments. Therefore, you cannot have a secret that sort of is connected to an environment, part of your code. That sort of makes sense, because if I have to add a new secret somewhere or in a new environment, I have to rebuild my software and, Okay, so loose coupling between secrets and applications enables secret rotation.
Yes. So, but if we not pay so much attention to the last one, we might fall into one misconception that we've seen. The first 2 talk about that when you make a build, it's not complete. There are things missing. the database password is missing. You need to, for it to actually to be able to run in the environment, you need to supply the password at some point of time. For example, it makes perfectly sense to then see that, okay, so I will not provide it at build time, I will provide it at deploy time.
In that environment.
It makes sense. So instead of having it built into the image, we say that when we deploy at startup, then we inject the configuration. We inject it, we bake it in the build pipeline, and there you go, and now you complete and can run. And it will run.
Only problem is then if you change the secret, you have to redeploy your services or apps.
And we can do that. For example, if we got 2 running instances with the secret X in an environment, and we change the secret to Y, then we start up a new variable with the secret Y, and that instance will be functional. The old instances with the secret X will cease to execute. They will experience failure, and they will crash and burn.
No, Dan, we can actually support 2 secrets, X and Y at the same time. And then you had you rotate it again, Z, right? You have to just support 3 secrets then. Or Omega 4, and the list goes on.
So
what did we...
So the problem is here that we want the application instances to be able to react on operational changes. For example, changing passwords for a database. The application instance should be able to react that this does not work any longer and hopefully self-heal in some way. So the way of doing this instead
is, of course, to fetch the secret on demand. Because whenever you need to use it, or let's say you have fetched it once, you try it, and it fails, well, let's fetch a new one. Because it could have changed, right?
So this piggybacks on the idea of re-healing applications. You make a retry. If you fail, you'll try to get the new secrets, you'll try to get the new IP addresses, you try to get the new freshened up, you freshen up and you make a new attempt.
Wait a minute, isn't this really good for availability? If you have a network glitch or whatever, you have to retry.
Or a database hiccup, something like that. So this makes it possible to actually, during operation, without restart, change database passwords and rotate them. So how often do you change your database password?
Me? Well, we try to do it as often as possible, right?
As often as possible, and that would be every year?
No, more frequent than that.
Every month?
Perhaps.
And
it's better than never.
It's better than never.
Yeah.
In practice, you could change it as often as once an hour.
Yeah.
Which, of course, makes wonder against the staleness. We have seen database passwords in production that are over a decade old, and that we're not going to have hands up here, but everyone who's got a database password in production that's older than 10 years, hands up. No, don't. We don't reveal that kind of secrets. But think of yourselves. Do we have any database password that should probably be changed? With this kind of solution, you can rotate them automatically.
Yeah. But let's look at some critique now, right? I think the important aspect here is that from having the secrets either in resource files or whatever you have it, you usually don't have it as a code line, right? As a variable in a class or something. You have it in resource files, and the problem then is like, we have it all these environments in here, so let's pull that out and supply it in our build pipeline, right?
So it was very clear that what we wanted to get away from. We wanted to get away from having to rebuild stuff to be able to change secrets. And we stepped away from it, but we didn't take a step long enough to get into where we really want to be.
And the problem is that if you take this wrong step of actually, supplying it at deploy time, you end up in a dead end, right? And it could actually end up in a way that you would never rotate your secrets because it takes so much time to rotate your entire cluster or whatever you need to do. You have to redeploy everything. So it's so tedious. You will never do it even though you've extracted it. And I think we were too eager to push for the fact of separating application and secret, right?
Another contributing factor might also have been the IT maturity at the time. Because if you say that you need a vault service in which you can store your secrets, do you have a vault service around in your data hall? If you look at on-prem data halls, you most probably do not have a vault out of the box, which means that you either have to buy something and install it, or you have to build it your own, like some database with some extra protection. But it's not a trivial step. Whereas if we look today, a few years later, the dominant factor is not on-prem, but cloud. And in cloud solutions, the IT landscape is much richer and always includes some kind of vault service. So it was so easy then to not see that it should be a vault involved because there was no vault in your data center and go for the easiest solution there, which would be bake it in at startup. Whereas now we see more clearly that no, the natural thing to do is to use the vault service because we have become used to it in our services that are in the cloud.
Right. So let's get back to our summary again. Now it all makes sense, right? So we have secure by design. It's a strategy and mindset for designing secure software by using good design patterns, right? That have that solve security issues, so to say.
And I would like to make a shout out to you. All of you are using favorite designs. I guess you all have that. Oh, I really love this. List of independent illustrators, whatever. Some design that you actually love. Take a look at that one. Take a second look at one. Are there any compelling security reasons, benefits under the hood? In that case, you are applying secure by design. Make yourself aware of that and speak to your peers and colleagues about it.
And of course, the misconception regarding domain primitives was that, we only focus on input validation, more or less. We create anemic objects, and that's it. And all the logic are pulled out of it, and so on. But we really intended that it's supposed to be intelligent machines.
So the second design pattern that we want to critique a little bit is the focus on validation, which was misinterpreted as a focus on input validation, which led that state validation was sometimes just left in the shadow. And at its best, validated implicitly and very seldom explicitly.
And of course, regarding the externalized secrets, what you just talked about is that, we should fetch them on demand and not supply them once at deploy time to avoid stepping into that dead end. Right.
So with these, we hope that we have given you pointed out a few of the pitfalls that we have encountered when applying these design patterns. We hope that you will avoid them, and we hope that all of us have come out with a little bit deeper understanding about what secure by design is about.
But we do have maybe a minute or two for a question, if there is any. So,
please, question or comments.
Oh, we have a question over there. So let's repeat the
excellent question. The question comment was that when we return information about when we get a state validation and return information about the state, does that reveal information to the attacker? And that's an excellent question where we need to thread carefully on the line. There are some things that we should definitely be able to return to the client. For example, if we say that you are sending me a malformatted taxpayer ID, it makes sense for me to return 400 blank bad request and say, I'm sorry, I can't do this. This is not a taxpayer ID, and you should know it. In the same way, in state, if you are returning, if we're getting an order for adding books to a closed order, it might make sense to say, I'm sorry, we can't do that because this order is closed. And you should know that you cannot add things to a closed order. And that is a part of the business logic that the client should already be aware of. So in that case, we don't reveal any new information to the attacker. Now, the distinction is, of course, if we are revealing things that are outside the acknowledged business domain. For example, technical details.
You mean like an exception? Oh, sorry, that's a different talk. Yeah.
For example, if we start phrasing that backend reaction in technical terms, no, we can't do this because our subsystem blah 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 is now blah 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 something. Then we are revealing information that could be of use for the attacker. So I think it's an excellent question, and the distinction line there is whether it's domain information, which should be known by both parties, or whether it's technical information or subtle information that not necessarily should be known by the client.
And that's our time, I think. Thank you so much.
Thanks a lot.